So we're talking about if I have a composition of functions, meaning a function inside of a function. Have we done that already this semester? Have we put a function inside a function already? Yes? What's that? Say it one more time. No, well, yes, it was in that because we did a limit, and what did we plug into the function x plus h, right? So that is exactly a composition of functions. When I'm putting another function inside of a function. So it turns out that when we do that and we take a derivative, we get the derivative of the outside function evaluated at the inside function times the derivative of the inside function. So I want to be thinking, and this is probably the hardest part about it, is what's the outside function? What's the inside function? So outside prime evaluated at the inside and all of that with the product of the derivative of the inside. Times the inside prime. So the first game that we have to be able to play is what's the outside function, what's the inside function, right? So if I give you y is the square root of x minus 2x, x minus 2x squared, what's the outside function? What's this operation I'm working on the outside here? Yes? Square root. So I've got a square root function with something kind of crazy inside now. And what's the inside function? It's clearly what's inside. What's inside? X minus 2x squared. So sometimes it's easy, sometimes it's not. What's the inside, what's the outside here? What's the outside? What is it? Nope. Nope. That's the derivative of the outside. The outside is actually a square function. X squared. But what's inside? Sine of 2x. So if I rewrite this, it's a little bit easier to see it. If I rewrite it like this, right? So you can clearly see it's something squared, right? That's what's happening first. But we use this notation just to make it a little bit more concise. What's the inside function? Sine 2x. So I'm going to have to keep that inside and then take the derivative, and then get the derivative of sine, which is cosine. But notice there's an inside of that. So there's an inside of this, and eventually I'm going to have the derivative of this. We're not doing problems yet. I'm just trying to play inside-outside game, right? What about this one? What's the outside function? T is an e to the x function, right? And then the inside function is negative 3x. So I'm going to teach you to do these chain rule problems inside-outside thoughts. I'm also going to give you a loop, okay? So this first one is pretty easy. This one is pretty easy to do right away. So original function is e to the x, derivative is e to the x. The inside function is negative 3x, the derivative is negative 3. My loop is going to do this. I want to do, so for y prime here, I want e to the x, but I want to put inside of it the original inside, and then multiply it by the derivative of the inside. So see if you see that here again. Follow you okay? Outside function is e to the x. The derivative is e to the x. The inside function, and I put the loop around it because I want this inside of this function. So notice that the x becomes negative 3x. And then I multiply by the derivative of that inside function. I like to think of this thing as a cat in a box. And it's not necessarily that I don't like cats, but I am more of a dog person. But so here's my cat in the box. That's the original function. Okay? What I'm gonna do is I'm gonna push it down. And now I can calculate how it's changing. That's the derivative, right? So I have to think about pushing down the hill. How is the box changing? Right? But the cat is still in the box. You with me? The cat's still in the box. So just because I'm getting the derivative of the outside piece doesn't mean the cat left the box. But the cat could be freaking out. You know what I'm saying? So I have to multiply that by how the cat is changing. The cat might be jumping around, right? So again, I want to think of derivative of the outside, keep what's inside, keep the cat in the box, times the derivative of the inside. All right, here we go. What was the one we had before? Y equals square root of x minus 2x squared, right? So outside function, do we know the derivative of a square root function? Hell yeah. 1 over 2 square roots. But I'm going to keep what's inside, keep the cat in the box. And then I'm going to multiply by the derivative of the inside. So notice I put the inside in parentheses and I put a prime on it because I'm going to take that derivative now. And so what do I get as a final answer? I get 1 minus 4x all over 2 square roots of x minus x squared. Make sure you see that, right? Make sure you see that. Square root function. Who cares what's inside? I'm just going to make sure it stays inside. So I take the derivative of a square root, that's 1 over 2 square roots, but keep what was inside. Then multiply that by the derivative of the inside. Right? And I just put a placeholder there because I didn't want to think too much. I said I know I still have to do the derivative of the inside. Right? So the derivative of the inside is what? 1 minus 4x, right? Now you should be doing these chain rule problems in section 3-4 right from the beginning. They start easy and they get very, very complicated, and we'll do a bunch of really tough ones. Let's do with and without the chain rule. So we'll start with y equals sine squared x. So let's do this one without. This is sine x times itself, correct? So how can I get this derivative? What rule? Product rule. First function in the product is sine x. Derivative is cos x. Second function in the product is sine x. Derivative is cos x, yeah? I want this product with a plus, so I get y prime is what? Sine x cos x plus another sine x cos x. How many are there? How many sine x cos x do I have here? 2. That's 2 sine x cos x, and what identity do you see there? Two sine theta cos theta is sine 2 theta. Right? These identities are going to start to show up. Make sure you get all those trig identities on your formula sheet. half angle, double angle, sum and difference, Pythagorean, all of them. All right, let's do it with now. So that was without, now with. Y equals sine squared x is the same as me saying sine of x quantity squared. So what's our derivative of the outside function? Something squared. What's the derivative? What's the derivative of x squared? 2x. So not 2x, but 2 sine x. Times the derivative of the inside. What's the derivative of the inside? Cos of x. And look what I get. Sine 2x. Same problem, same answer. The thing about the chain rule is we've been doing it all along, but I haven't been telling you. Right? What's the derivative of sine x? Cos x. Times the derivative of the inside, but the inside is x, so the derivative is 1. Foreign. Didn't need to do it, right? But I made sure that all your problems had a derivative of the inside at 1. Another one with and without. Yes, we ready? So y equals e to the 2x. So this one, let's do with first. Let's do with the chain rule. So I'm going to do, my outside function is e to the x. Derivative is e to the x. Inside function is 2x. Derivative is 2. And I want to do a loop where the derivative of the outside gets evaluated at the inside. Keep the cat in the box and then multiply by the derivative of the inside. So I get y prime is e to the 2x. Is that making sense there? You see how I put this thing inside? So I want to take that and put it into the placeholder in the original function and then multiply by 2. Without. How are we doing here? We okay? Is this agreeable? Top right corner? When I multiply like bases, what do I do with exponents? Add them. So x plus x is 2x. But now I have a product rule, right? I have a product rule. And so when I do my product rule here, all functions are e to the x, all derivatives are e to the x. What do I get for y prime? I get 2 e to the x, I get e to the x times e to the x plus another e to the x times e to the x, right? So that's 2 of those. And then, of course, when I'm multiplying like bases, I add the exponents. Same answer. How are we doing? What, you're all just pissed off about your test scores, or what is it? We okay? Are we following? Let's move right to a tough one. Okay, so let's move right to a tough one. I like 3.4, number 17. Yeah, It's fine. 3.4, number 17. I've got y equals 2x minus 3 raised to the fourth power, and then x squared plus x plus 1 raised to the fifth power. So notice the insides. Is it pretty clear where the inside is? I mean, there's two insides, right? One of them is inside the fourth power outside function. One of them is inside the fifth power outside function. So I'm doing the product rule and the chain rule. I will always use the chain rule on every problem for the rest of my life as a mathematician. Okay? Chain rule all the time. Product rule only when you have a product. So my first function is 2x minus 3, that quantity to the fourth power. What's the derivative? Power comes down, right? Yep, 4 times. Good, to what power? Good. And then derivative of the inside? 2. Second function, x squared plus x plus 1 to the fifth power. Derivative 5 times that sum, but to the fourth power times what? Yeah, 2x plus 1. I am doing the product loop in any order I want. I kind of like them in this order. So I get y prime equals 8 times 2x minus 3 to the third times x squared plus x plus 1 to the fifth. Is everybody following? Plus this piece, which is what? 5 times 2x minus 3 to the fourth times an x squared plus x plus 1 times a 2x plus 1. Everybody with me? I want to factor. Don't distribute. Some of you are distributing when you shouldn't be. If I'm using a conjugate, only distribute where the conjugates multiply, right? If I am doing an LCD, only distribute where my fractions need to cancel, right? Otherwise, leave it alone. We want to keep things factored as much as we can. So it looks like I can take out a 2x minus 3 to the third power, right? Because notice I have it to the third power and I have it to the fourth power. I can always take out the smaller power. And an x squared plus x plus 1 to the fourth power. Oh, sorry. Yeah, this is to the... I lost my fourth power here, sorry. Right? So this is factored out already. Right? This is factored out already. How many, what else do I have left? I have an 8 left. Right? I'm looking here. I have an 8 left, and how many of these left? 1. Then I have a 5 left, and I have a 2x minus 3 and a 2x plus 1 left. We're trying to factor everything. What I'm eventually looking for is something called critical values. Critical values are when the derivative is 0 or when the derivative is undefined. That's when the derivative has a numerator equal to 0 or the derivative has a denominator equal to 0. Right now, I can already see a critical value of 3/2. This one is never 0. And I'll show you how I know that in a second. But the other piece I still might be able to factor. So I'm going to keep going. Every time I write a new line, I'm trying to write a complete sentence. So it looks like I have 8x squared plus 8x plus 8 plus 5 times 4x squared minus 4x minus 3. Someone double check me on that, please. Anybody? Yeah, Jeffrey, thank you. And so I just want to distribute that 5. And then combine like terms. I think that's my final answer. I'm going to go to the book and check it. That last quadratic does not factor nice, but it does have zeros. So we'll say in general, if the zeros are irrational, don't bother factoring, okay? If the zeros are irrational, don't bother factoring. And they turn out to be irrational here. So if I look at Desmos, when I graph x squared plus x plus 1, that's one of my factors. You see it doesn't have roots, so it's not factorable. When I graph the other one, what was it, 28x squared, what was the middle one? Don't worry, I'll do it myself. Minus 12x. So this one, you see I have roots, but they turn out to be irrational. So when I get irrational roots, I won't bother factoring. I still will have to find those critical values. And I can either use quadratic formula or complete the square, right? Anything you want. But that's my end derivative right there. So you got to be organized, right? You're going to have to be neat. You can't worry about wasting paper. A lot of you did a real good job of, when it was a 2-part problem, doing one part on the first page and then one part on the back of the same page. That was great. Let's do another. Let's do 25. So I've got y equals x cubed minus 1 over x cubed plus 1 all to the 8th power. So it's pretty clear that the outside function is something to the 8th power, right? And we know how to take that derivative. The power comes down and we reduce the power. So 8 times that inside, keep the cat in the box, reduce the power, but then take the derivative of the inside. And I don't know if you see it, but what rule are we going to use? Yeah, quotient rule, right? Yeah. So notice I took the derivative of the outside, right? I took the derivative of the outside. I kept what was inside, and now I'm working on taking the derivative of the inside. So I like to put that placeholder in so I don't have to do the whole quotient rule at the same time I'm just trying to work on the chain rule, right? So now I'm going to work on my quotient loop, right? I've got x cubed minus 1, and derivative is 3x squared. Then I've got x cubed plus 1, derivative is 3x squared. And then I have to make sure I get x cubed plus 1, that downstairs squared. So now you can see I'm going back to y prime. I still got 8 times the inside, but to the 7th power. And now I'm ready for my quotient loop. I know it's going to be x cubed plus 1 quantity squared downstairs. And then what do I have? 3x squared times x cubed plus 1 minus 3x squared times x cubed minus 1. Everybody with me? I don't like to distribute. I like to factor. I can see that I can factor out a 3x squared here. Right? So I get 24x squared times x cubed minus 1 to the 7th power. I get an x cubed plus 1 to the 9th power. Make sure you see that. And then I have an x cubed plus 1 minus an x cubed minus 1. I'm trying not to do too much. I'm trying not to distribute at the same time. You'll see a lot of places on your test where I put parentheses in that you missed. Right? So look for that. Try and be careful. It looks like what? I'm going to get a 2 out of that. So here's my y prime, 48x squared over x cubed minus 1 to the 7th over x cubed plus 1 to the 9th. Done. So I want things factored for where we're moving. We're moving to chapter 4. In chapter 4, I have to find critical values. It's where the numerator is 0. Which number is that? What number would make this 0? It's obvious. 0. What number makes this 0? 1. What number makes this 0? Negative 1. So we're factoring because I can find the zeros quick. We've been doing that for a long time in algebra. Get everything factored so you can find the zeros. We need the zeros because they tell us certain things about the function. That's chapter 4. Yes? Yep. Let me go. Tell me where. Okay, in step 4. Yeah, so I factored that out, right? I took those 3x squareds out, and the 8 became 24x squared. Now what's left? X cubed plus 1 minus x cubed minus 1. So the x cubes will cancel, and the 1 plus 1 is 2. So that became now 48x squared. One more? Yes, one more? Okay. Oh, 54, nah, that's boring. Let's do 20. Since you're obviously, you're the best class, I can put even more difficult problems on your exam, right? So you make sure you're ready. Make sure you do all of my old exams. Make sure you do all my old midterms. Start on it now. You're almost done. We only have 3 more seconds to do. But you can do half of those exams now. I guess 3.1 is shortcut derivatives. 3.2 is product quotient rule. 3.3 is Triggs. 3.4 is chain rule. 3.5 is called implicit differentiation. 3.6 is inverse Triggs. And 3.7 is logs and exponentials. We've already done the exponential function, how to take that derivative, but I'm going to prove it to you when we finally get there. So that's our next test right there. There'll be tangent lines on the test. There could be a limit, a derivative using a limit, and then double check with the chain rule. So you still have to be able to do everything on that first test. All right, let's do number 20. 3.4, number 20, then we'll quit. I want to see, Hoy, I want to see your test. Jack, I want to see your test, okay? And if anybody else wants to talk about it, that's fine. So number 20, I have 3x minus 1 to the fourth power and a 2x plus 1 to the negative third power. I find this one easier if I go quotient rule. So if I take that negative power and move it down and do it with the quotient rule, I find this one, it's a little bit easier. But I'm going to do it as a product rule now, because I want you to try it on your own as a quotient rule. Of course, you should get the same answer. So my first product is 3x minus 1 to the fourth. What's the derivative? 4 times 3x minus 1 to the third times another 3. Derivative of the inside. The other function in my product, 2x plus 1 to the negative 3, and the derivative is negative 3 times 2x plus 1 to the negative 4. Remember, I have to reduce the power by 1 times another 2. Everybody okay there? I'm going to write out this product rule, but I'm using this loop because when I do a product rule, it doesn't matter. I can do any diagonal plus the other diagonal. So I'm picking this diagonal first, just so I get a nice leading positive coefficient. So y prime is 12 times 3x minus 1 to the third times a 2x plus 1 to the negative third. Everybody with me? And then I need this loop, right? So that's a minus 6 times a 3x minus 1 to the fourth times a 2x plus 1 to the negative 4. For my green factors, what's the smallest exponent I have? Three. For my blue ones, the green ones, what's the smallest exponent I have? Jack? Yes. So 12, right? 3x minus 1 to the third. Yeah. Yep, 3x minus 1. So I can take out a 6. I can take out a 3x minus 1 to the third. I can take out a 2x plus 1 to the minus fourth. This bothers most students. You fix it by doing the quotient rule instead, okay? But what's left over for me? What's left over for me here? 2 times 2x plus 1 to the first power. Remember, when you're multiplying like bases, you add the exponents. So negative 4 and positive 1, right, will get me that negative 3. Minus the 3x minus 1. Make sure you're okay there. A lot of students don't like this kind of factoring. The fix is to do when you have negative exponents, move it to the denominator. Okay? One of the things that you're not doing is when you factor, you better distribute back to double check. Right? So when I multiply this 6 and this 2, I get the 12. When I multiply this to it, it's the same factor. When I multiply this to this, I get the negative 3. Right? So you want to, after you factor, you want to double check it. All right, what do I have now? 6 times 3x minus 1, quantity to the third, 2x plus 1, quantity to the minus fourth, and then I've got a 4x plus 2 minus 3x plus 1. It looks like I have an x plus 3 there. And final answer, with all positive exponents, done. Checking in the book, checking with the answers, making sure you're also checking with Desmos every now and then. You want to not lose that skill, that ability to do that. What are my criticals? Critical. 1/3. What's my critical here? -3. What's my critical here? -1/2. You're talking in the back. I can't tell if it's because I didn't take my medicine or if the voices are in my head. Please, if you have a question for me, ask, okay? All right. We're done today. Look for my solutions on Blackboard.